Hey guys, so in the previous video we were talking about oxidation numbers, and we saw that oxidation number is actually a charge on any element, and it tells us whether the electrons have been gained by it, lost by it, or nothing has been done by it. If the oxidation number is 0, which is the case with pure isolated elements, it's going to be an indication that it hasn't reacted, no electrons have been gained or lost, and that is applied only to pure elements, the elements which are written separately, whether they are written with a number or just in the purest form. Negative oxidation number means that electron has been gained by the element. Positive oxidation number means the opposite. It means that the electron has been lost by the element. So oxidation number means very simple things. If it's a pure element, it's a 0. And we also talked about how we calculated the oxidation number of individual elements using the other oxidation number. Because by the end of the day, the oxidation numbers have to be equal to each other. So in today's video, we're going to be trying out few equations and we're going to see if we remember the ideas we had done so far. For example, the first equation is pure copper and it's becoming copper nitrate. There must be something else as well, I know, in the equation, but I haven't written it. I've kept it very simple. Pure copper is becoming copper nitrate. I have no idea what's the oxidation number of pure copper or copper in the copper nitrate. But let's see. If it's pure copper in the beginning, it's just CO. It has to be a 0 because it's element. It's not with any other element, not with any other compound. So it's got to be 0. In copper nitrate, the copper is with two nitrates. So individually NO3 as a whole is equals to -1 because it has a -1 charge. If it's two NO3s, it has to be -2. And obviously copper as a whole becomes +2. So copper is turning from 0 to a +2. That means copper is oxidized over here because now it's changing the oxidation number from a 0 to +2. It's losing the electrons. Oxidation number increases. It is oxidation. Let's see at the iron. So iron was previously with 3 Cls. Each Cl is a -1. So 3 Cls have to be -3. Iron, obviously, to counter it has to be a +3. So iron has an oxidation number of +3 in the beginning. By the end, it's only 2 Cls, which means double -1. And iron has to be +2 to counter it. So iron is changing from a +3 in the beginning to a +2 in the end. And that has to be a reduction process. Because the oxidation number is decreasing. It's changing from +3 in the beginning to +2. And that's a decrease in the oxidation number. Whenever the oxidation number decreases, it is known as reduction because electrons must be gained by it. Let's try out another example. We have copper over here, we have chromium over here, and there are 3 chromiums. There are 3 chlorides. Each chloride is a -1, and 3 chlorides must mean it's a -3. Chromium has to be +3 to counter it. So each chromium is +3 over here, but by the end it's just chromium, nothing else. So what do we say when it's an individual element? The oxidation number is 0. So it's changing from a +3 to a 0, again a kind of decrease. And whenever the oxidation number value decreases, it's a reduction process. So that's again a reduction process. Let's start one more example with lithium. So lithium in the beginning, you guys see, lithium in the beginning has nothing around it. So it's a 0 over here. It's a pure element. But by the end, it is reacting with oxygen. So we already know that, with reaction with oxygen is obviously an oxidation process. But let's see. Oxygen is always a -2. Lithium has to be +2. But there is not only one lithium, it is a double lithium, Li2. So if lithium with 2 is a +2, if there are 2 lithium atoms which is a +2, individual lithium has to be a simple +1. Lithium with double atoms, with 2 lithium atoms, it was +2. We talk about individual ones. We never quote the oxidation number for multiple atoms at once. We always quote it for a single atom. So lithium individually is a +1 right now. So it is changing from 0 to a +1. It's increasing. And increase in oxidation number is an oxidation. Because increase means that positivity means that electrons were lost. Only positivity comes when the electrons are lost. Let's show out this example. Now this one is really cute because we'll see what the answer comes out to be. Let's use some other color. Let's suppose pink. A nitrate as a whole is a -1. So silver has to be +1. Silver in the beginning is a +1. I know that Cl is also a -1, and as a result silver again is a +1. So silver is not changing itself. It's no change in oxidation number. It remains the same. So remains the same. It means that it's not a reduction or an oxidation process. It has changed a partner, obviously. It was previously with a nitrate, now it's with a chloride. But it's not a redox reaction, so it's not redox process. Let's solve now complicated equations. Let's see. So we see that it's an iron with a +3. How do I know this? 3 Cls mean a -3. Iron has to be +3. I know by the end of the equation I can see it's just with a 2 Cl. So it's a -1 with a double. So it is 2 Cls, which means a -2. Iron has to be +2. So it's changing from +3 to +2. I'll make a line over here, which is a very simple idea to deliver the concept, that iron is changing from +3 to +2. And that means it's decreasing the oxidation number. It's a decrease in oxidation number, which means it's a reduction. Reduction means decrease in oxidation number. Let's look at the tin chloride. I can see that it was previously a -2. So it is 2 Cls. Tin has to be a +2. But by the end of the equation I can see there are 4 Cls, which means it is a -4 charge. And tin has to be +4 to counter it. So tin is changing actually from, let's say I'll make the line over here properly. Tin is actually changing from +2 to +4, and that's an increase in oxidation number. Increase in oxidation number, which means it's an oxidation process. So when something becomes more and more positive, it is oxidation for it. And when something becomes more and more negative, it's obviously the opposite, which means the reduction for it. I have one more equation over here, and let's try this one out. Now in the beginning I have some kind of iron oxide, because I can see it's iron combined with oxygen, so it has to be some kind of iron oxide. Let's see the oxidation number over here. I can see that there are 3 oxygens over here, so each oxygen is a -2, and 3 oxygen means a -6. So it's a -6 over here. Iron has to be +6, obviously. But there are 2 irons over here. So if 2 irons are +6, individual iron has to be +3. So I can see that iron is a +3 over here. So I'm writing iron is a +3. But by the end of the equation, iron is alone. Iron is a separate pure element, which means it's a 0. So it's becoming a 0. It's changing from +3 to a 0. So I can very safely say it's changing from +3 to a 0 over here. And that means it's a decrease in oxidation number. It was previously a +1, or sorry, +3, but now it's a decrease in oxidation number, so it's a kind of reduction. Let's look at the carbon. I can see that carbon was with an oxygen. Oxygens are -2, so carbon has to be +2. And by the end of the equation, it's not just 1 oxygen, it's 2 oxygens. So I can know that 2 oxygens is a total of -4. It's not 1 oxygen, because 1 oxygen is a -2, but 2 oxygens would be -4. And carbon has to be +4. So carbon was previously a +2, but by the end of the equation it becomes a +4. And that's an increase in the oxidation number. So it's an increase in oxidation number for carbon, which means it's an oxidation for the carbon. And you would already notice that carbon is reacting with the oxygen. You know, carbon had previously 1 oxygen, now it has a double oxygen, which means that the amount of oxygen is increasing. So we can say that iron is reduced, the oxidation number changes from +3 to 0, and we can say carbon is oxidized because the oxidation number changes from +2 to +4. So it's a decrease in the oxidation number for iron, and it's increase for the oxidation number of carbon. So आयरन का ऑक्सीडेशन नंबर यकीनन कम हो रहा है, प्लस से 0 पर आ रहा है. कार्बन का ऑक्सीडेशन नंबर बढ़ रहा है, +2 से +4 पर जा रहा है. So this is how we find out redox reactions going on. So let's take out a moment to revise everything we have done so far. We know that redox reaction is a complicated process, which means it is gain and loss of electrons. So loss of electron is oxidation, gain of electron is reduction. Whenever oxidation occurs, the charge becomes more positive, and obviously the negative for reduction. So whenever reduction happens, the charge decreases, it becomes more and more negative. Either it comes to 0 by decrease, or it even goes below 0, like -1, -2. Then we saw that generally even oxygen and hydrogen are used to describe reduction reactions and as well as oxidation. So we saw that oxidation number is the idea about the 0 or the +1 or the -1 on charges. We know how to calculate the reduction and oxidations using the oxidation numbers. If the oxidation number is increasing, it's an oxidation. If the oxidation number is decreasing, it's a reduction. And then we saw redox reactions go on simultaneously. So if the oxidation number is increasing, it's an oxy, and if the oxidation number is decreasing, it's a reduction. So we can find that out as well.